Okay guys, I'm recording this in the case that I don't make it to school tomorrow. I'm not feeling very good, and after you're done with your quiz, you can watch this and finish the notes for 1.4, then do your homework. So, domain of a function. We already covered this, numbers that are possible for independent x values of a function. We cannot have a division by 0 or taking the even root of a negative value. So, going on to that, there's two more examples of where we can't divide by 0 and taking the even root of a negative. So, what we're saying is that this bottom cannot equal 0. So to find which values make it equal to 0, let's solve it. If we have x squared minus 2x equals 0, factor out the x, you still have x minus 2 equals 0, then set each of these factors, x and the x minus 2, equal to 0. And we know that x can equal 0, therefore, then do x minus 2 equals 0, solve for x equals 2. X cannot equal 2 because if you plug in 0 into this denominator, it's going to turn out to be 0. 0 squared minus 2 times 0 is 0. Same thing if you plug in 2. 2 squared is 4, minus 2 times 2 is subtracting 4. This will still turn the denominator into 0. So our restriction is that x cannot equal 0 and x cannot equal 2. Going down here, this fourth root of x plus 6, what we know is we cannot take the even root of a negative. So we have to realize that x plus 6 has to be greater than or equal to 0, no matter what the x value is, because it cannot be negative. Solve for x, and you get x is greater than or equal to negative 6. So if we're going to write our domain, we can write it with the brackets as I showed you guys yesterday. With a lower limit, the minimum it can be is negative 6, and the highest it could try to be is infinity. But it will never touch infinity, and that's why we use parentheses, whereas it can be negative 6. That's why we use this bracket. And another way that you could have written this is that domain is where, sorry, that's terrible. Negative 6 is less than or equal to x, which is less than infinity. I prefer just writing that with the bracket and the parentheses. Piecewise functions. Functions defined by two or more equations over a specified domain. When graphing, graph each equation separately over the specific domains. Watch the beginning and ending points. So, what does that mean? It means, well, I'll show you what to do. It means that if we have this function and it's made of piecewise, so it's made of two different functions over two different domains, the domain will tell us which function to use for the given x. We're trying to find the function of negative 1, the function of 0, and the function of 1. Those are our values of x. Now, when x is less than 0, we use x squared plus 1. Well, negative 1 is less than 0, so therefore we're going to use x squared plus 1, put in negative 1 squared plus 1, and you get a value of 2. When x is equal to 0 or greater than 0, you use x minus 1. So, in place of x, we have 0 minus 1, value of negative 1. And then for f of 1, 1 is greater than or equal to 0, so we're going to use that same function. In place of x, we have 1 minus 1 equals value of 0. Go ahead and try this one on your own. Stop the video and then check to make sure that you did it right after you've seen me do it. Okay, so we need to find h of 0, h of 3, and h of 5. 0, that would be less than 2. So I'm going to plug in 0 for this equation. I get 3. 3 falls between 2 and 4, so I just get a constant of 7. And then 5 is greater than 4, so I'm going to use this function, 2x minus 1, plugging in 5 for my x, and I get a value of 9. When we're graphing a piecewise function, we're going to leave any range that's greater than a number, greater than or less than a number, with an open dot, and any range that is greater than or equal to or less than or equal to with a closed dot. I'll show you what I mean. X squared plus 1 is usually drawn like this. Now, but we're only interested in where x is less than 0. So x is less than 0 would be all the values going to the left. So I'm going to erase all the values from the right, but it doesn't equal 0, so I have to leave an open dot where x equals 0. Then I'm going to move on to the next function, x minus 1. That would usually look like this. But we're only interested in the values where x is greater than or equal to 0. So all the values to the right of the y-axis. So I have to erase all of that. And since it's equal to 0, I'm going to put a closed dot. Oh, undo that. Put a closed dot there. Make that line as straight as I can. What that means is that any of the values to the left of 0, we're going to use, any x values to the left of 0, we're going to use this top equation. This is quadratic. But any values at 0 or to the right, we're going to use this bottom function. Follow that line. Try this one on your own and then check mine. So stop the video. Alright, so I'm going to do this. Okay, so we have 2x plus 1. That's what that looks like. And then we're only interested in where x is less than 0. Excuse me, 1. So we're going to go to where x equals 1. That would be at 3. We say we're only going to the left of that. So I'm going to erase everything to the right. And since x is less than 1, I have to leave this as an open dot at that value. Then negative x, 1/2 x minus 3, where x is greater than or equal to 1. So that's going to be, go to negative 3, go down 1 over 2, down 1 over 2, down 1 over 2. That's what it should look like. Same thing going to the left, okay? But we're only interested in where x is greater than or equal to 1, which would be right there. So everything to the left of it that's less than 1, I don't want. So I have to erase that. We're going to start right where our x was 1. I'll put a solid dot there and follow the dots that I already plotted. One more for you. Go ahead and graph these on your own and then check my answers. Stop the video, start back up. So where x is less than 2, I'm going to just see where x is 2 for that first one. So it's negative 2 times 2 plus 5. And then I know I can follow this line to the left of it. So negative 2 times 2 is negative 4 plus 5 is 1. So at 2, 1, I'm going to have an open dot. And then I will graph that. Now I go through 5. I know it goes down 2 over 1. Same thing backwards. Then I know that from 2 to 4 it's going to have a value of negative 1. So at 2, negative 1, and then also at x equals 4, negative 1, it's going to be a solid line. I put solid dots in because they're equal underneath the inequality there. And then we have x is greater than 6. We use this. So I'm going to see where what y value I'm going to have in it when I actually plug in 6. So 1/2 times 6 minus 3 is 3 minus 3 equals 0. So at 6, 0, I'm going to have another open dot. And then I can follow that line. 1/2 x minus 3 would go right here. Negative 3, 1/2, 1/2, 1/2. It would follow that, but then it hits this. Then I go up 1/2, up 1 over 2, up 1 over 2 from there, and that's when x is greater than 6. So I'm only going to do the right part from that point. I don't care about these 2 points, so I'll erase them. And that's all there is. So as you can see, there's gaps from where x is greater than 4 to x equals 6. We don't have any values, but that's alright. This is your homework. Please do it as much as you can and be ready to ask questions when I come back if I need to be gone.